Hello everyone. Good morning.
Good morning, sir. How are you, sir?
Morning. I'm good. How about you?
Pretty good, sir. Thank you.
Pretty much we need to wait upon the 10 of them on the We'll just start our class with next 5 to 6 minutes. Guys, those who have not attended the previous classes, please do go and watch after this class. Okay. And please subscribe to the YouTube channel. Why? Because it's very important to know the basics first, right? So we covered a lot about the basics in the last three classes, right? We talked about compute services, databases, and the introduction basis. Please subscribe to the YouTube channel, and I think so in the group description you can able to see the YouTube channel link. Go ahead and watch the your YouTube videos and get to know the basics so that it will help you a lot, right? Why? Because blindly, if you're joining for this class newly, it will be a huge back for you. So please kindly watch those things. And as you know that the pre-booking has been started for Cloud Developer Associate, and it is very happy to see that CDP Networks is providing 50% offer for you guys. So those who are attending the sessions and you're all, so I also have a lot of benefits like you can able to access all those contents and you can also access to the CDP community. So please make sure that the enrollment link is available in the group and please fill the form and get enrolled and you'll be under like what can I say uh, full-fledged lecture we'll be providing with focusing on the interview preparation and we'll also what can I say provide you the other additional things which is needed for you to right and please give your social media reviews like Google review for us, but because this will help us a lot to continue our training in the next bigger scale. But because reviews are very important for all the trainers as well as those who are like, organizing this particular training. Reviews are very, very important, guys. So please do the needful. Right? Okay, let's time up. Let's start the class today. So in the last class, we just talked about databases, right? So we covered some of the databases, and as I said, there are a lot to know about it, and we talked like we provision everything under the scale what we are expecting to do that thing. So today, as the content has been shared to you. Right. So today we're gonna work with the other compute services which is available. Uh, the other computer service available in AWS, and moreover we'll be focusing today with Docker and containerization. And guys, I would want to specify that I'm not a Docker specialty here. Right, I'm not a container specialty over here but because they need a huge level of knowledge in Dockers and containers in and public repos and private repos, etc. But here I'll be giving you the basic overview about how to what can I say, what is Docker, what is containerization, and what are all the tools or what are the services available inside here, inside Amazon Web Services, right? Inside AWS will be seeing. So that's a quick glance. We'll be going into it. And also today I'll be what can I say, sharing you the one of the biggest or one of the most fascinating advancing technology, advancing concept in terms of cloud computing, which is nothing but serverless, right? But because so far so go, we talked a lot about that. You need a virtual server to set up everything what you needed but there is an other hand and blindly an opposite thing which is available in cloud computing, which is none other than the serverless, where you don't want to provision any kind of infrastructure needed for your application. And finally, ending it with cloud integrations. We'll be ending it with cloud integrations today. And if we have time more, we'll be dealing with some of the hands-on if it is available. And we'll try to push some other services which is needed for you to give you a much more overview about what are all the other services which is available. I'm pretty much excited for this. Let's start the class today. Can anyone please quickly check whether my screen is visible?
Yes,
Okay,
yes,
thank
sir.
you. Thank you so much. Just give me a minute. Okay, fine. Thank you. So let's start with Docker and the containerization. So first of all, what does mean by Docker and why we need a concept called as containerization? Why? Because a lot of solution architect people, a lot of DevOps enthusiasts, like the developer operation people, will be using this Docker and will be using the containerization and the other scale up what is available in terms of DevOps enthusiasts called as K8, which is Kubernetes. So today we are not going to talk about Kubernetes because it's an advanced concept in what makes advanced concept in AWS. And for the cloud practitioner level, EKS like the Elastic Kubernetes service, which is available in AWS, it is not needed for you at all. But if you go more, like if you want to learn more into it, it is nothing but the extraction of Kubernetes and which is available inside your AWS. Okay, pretty much. Don't I want to put you in a scale, right? You need to be fitting in the scale, right? Okay, let's start with this thing. So, what is Docker? So, Docker is all about the concept which is being familiarized, like the word containerization. So why the concept called as containerization has been released? Why the cloud native technology has been released in terms of Docker and terms of containerization? So first, let's take an instance that I'm creating an application. I'm creating a software, a SaaS product, a software as an as a SaaS product inside my computer, right? Inside my system, I'm creating a SaaS product. Now, my system has some what can I say preferred configurations. Let's say it has a Windows operating system with RAM, ROM, and a graphics card, etc., and other configurations it has. Now, since it is a SaaS product, have been developed, and what may I say? One Another thing is, since the product has been developed by me, I need to what may I say? Sell this product to the customers, right? Why? Why? Because I'm the developer who developed this product. Now I need to push this product to the market, and this market should and the users, the consumers, need to use this product. What they'll do? They'll try to download the product and they'll so it's a SaaS application, right? So they'll download the application and they'll start working on the application. But unfortunately, what happens is nothing but since the product has been built myself, I do have lots of system configurations. Like this product will be working under only Windows 7, Windows 8, or greater than Windows 7. Yes, and RAM should be at least 4 gigabytes of RAM and ROM should be at least like it should have almost 128 gigabytes of space. And GPU configuration, it should have at least NVIDIA 1615 Ti. So NVIDIA 1615 Ti should have. So these type of configurations are available for the product what have been developed. So unfortunately, the consumers we can't able to expect that all the consumers inside the mind in the market can able to have the same configuration what they have, right? So they may have other OSs, like they do have Mac OS, they could have what can I say, Linux OS or other OSs, like and the RAM what can I say, might be less than 4 gigabytes what they have, because they might have the less version what they. So just for an instance, I'm just saying. So what happens now? The product cannot be used by the consumers. Like the customers can't able to use the product what is being developed by me. So it's still going to be a biggest issue. Why? Because it's very important that as a product developer, I can't able to predict everything in advance in such a way that all the consumers in the market will have the same system configuration what I have developed, right? So what is the biggest solution what I can do? So what is the other solution where it makes it much more easier way for the consumers to use my product? That's the concept which is being arranged, or what's the concept which is being what may I say erased called as containerization. What is containerization? You may ask the question, what is containerization? I'll be giving you a basic overview about the containerization, and we'll be delving into some of the services today. Fine. So what happens over here? So instead of making the product as a public, right, rather than download and install, customers go download and install my product and use it. Unfortunately, your system configuration does not met my product. What happens in the particular way? We need to make sure to provide in another way for the consumers to make sure that the product is useful to them. What I can do is nothing but since let's say it's a SaaS product, it contains both front end as well as the back end code part, right? So it contains both front end. Let me choose another color for this thing. So it contains both front end and back end, right? So with your favorite programming languages, I would say front end is written with React and back end is written with Java and .NET, etc., and everything. So kind of problem. So what happens is nothing in another way that what I'll do is nothing but instead of making it as a public to the consumers, what I'll do is that I'll make it as an image, which is nothing but a component inside Docker, which makes sure to have it as a single image, single what can I say, piece of thing which can be available to the consumers. And I'll also make the backend to the image. Okay, so what happens is that now the image is being so these are being what can I say termed as Docker images, where the Docker images will contain what happens is nothing but I'm gonna what can I say couple all the front end part and as well as I'm gonna couple all the back end part inside one single what can I say single piece of thing which is called as Docker image. Now I do have this Docker image in my hand. I'm gonna push this Docker image to an public repository where I'm gonna push this Docker image to the public repository. And that public repository will contain the Docker image for your front end and will contain your Docker image for your backend. Now, so far, so go. Now, what happens? The product what I've been created, it has been we have it has two different parts, front end and backend. Now, I coupled the front end into a Docker image, a single thing, the thing which is available as an other thing, like which doesn't what may I say. More important thing in terms of Docker image is nothing but you don't want to think about the configuration at all. And backend is also being coupled into Docker image. Now I'm going to push this Docker image to a public repository, which is provided by Docker, so that in that public repository, both the Docker files, like both the Docker images, both the front end as well as backend is available. This process is called as containerization. What I'm doing it, I'm containerizing both front end and backend in terms of Docker image. I'm storing this Docker images inside a public containers or public, I would say it as a public containers called as Docker public containers, where inside the public containers, I can able to see that thing. I can able to see that thing. I can able to find both both the Docker images called as front end as well as backend. So this process is called as what can I say containerization. Now you might ask a question: how the consumers can able to access this Docker images? That's very simple. Now, since it is a public, what can I say, public registry, which is available, now consumers also has an access to the public registries, right? Now, what they'll do something, but they'll take both the Docker images from the public registries and they will run the Docker file, right? They will run the Docker file instead of what may I say in running the product at one go. They'll run the Docker images at one, like both the Docker images, like both front end as well as back end as well. Okay, they'll run the Docker images. Now you might ask a question: what is the difference between running the SaaS product directly as well as running the SaaS product as a Docker containers, like the Docker images? The very important thing, nothing but since the SaaS product has been developed by the developer, like by me, I have been directly produced to the market without knowing the system capabilities. Why? Because the consumers may do have a lot of different system capabilities. But in terms of when I'm doing, make sure when I'm doing in such a way that when I'm doing such a way that consumers can't able to use the product efficiently and only what I say a range of 50 to 40 to 50% of consumers can able to use the product. But instead, what I can do another way, right? Instead of pushing the product to directly into the market, I can make sure to containerize the application into Docker images and push it to the public registry, where I don't care about any kind of public and any kind of configurations in that thing. Why? Because Docker images are same for each and every system what we have and each and every operating system which has different configurations. Why? Because it is going to run simply. We don't want to care about any kind of configuration in terms of Docker images, right? So this is the concept behind containerization. right? Why containerization has been released? Why? Because to make sure that it has a lot of what can I say, we can't able to do in such a way that every system in the every consumer's product, what can I say, platform will not be compatible to the product, right? Will not be compatible to the product. To make sure that every customer want to use the product, we need to containerize our application in such a way that it does not affect the configuration of the product which is being developed, right? So this is the what can I say, a plain what can I say? I would say it's a plain thing. Why? Because to understand what is all about Docker, what is all about containerization, I would say that this is a basic example or basic understanding as a beginner you need to know. Why? Because there are a lot to know about in Docker, right? Okay, there are a lot to know about in Docker. You need to know about public repos, private repos. Then you need to know about the registry. Everything is known to be advanced, but this is the very basic thing you need to know, like before entering into the other services in AWS. And moreover, right? And moreover, let's see the what is being given over here. So as I said, a Docker is a software development platform to deploy your apps, where you can deploy your apps and you can make sure to customers can able to use your product from that particular development platform. Apps are packaged in containers that can run on any OS. As I said, they are coupled inside a containers as a Docker images. That's very simple, guys. So as I said, this is the front end, this is the back end. Okay, I'm gonna have it as a Docker image, and for backend, I'm also going to have a Docker image. What I'll do is something, but I'll push it inside a container. This is called as Docker container. And inside Docker container, we'll push both the Docker images, right? We'll push both the Docker images. Now, so that's why it's said. So apps runs the same regardless of where they are run. That's it. So they don't have any compatibility issues and works with any kind of operating system what you have. So they doesn't depend upon operating system what the product has been developed, what the application has been developed. Doesn't depend upon that. But what the thing is, you need to use it. The customers want to use my product. That's where you need to what means you have to Dockerize your application and you have to deploy your application inside that Docker platform, right? And you can also scale up your containers down, up and down very like quickly. So that's is also one of the important use case where you need to work on. So yes. So where the Docker images are stored, as I said, so you are being containerize your application, right? Your application consists of both front end as well as back end. Now you are containerize your application, like you have make your Dockerize your application as Docker images. Now you may ask a question, where the Docker images are stored? As I said, the Docker images are stored inside the Docker containers, right? So stored in the public Docker repository or public Docker containers or public Docker registries, any kind of things, guys. So what we have. So public Docker repository, I'll just show you the public Docker repository in a minute. So this is the public Docker repository, guys, where you can able to find all these, what can I say, um, your it's a software development platform which consists of all the other apps as a Docker images. Like so, when able to see it contains all this container images. Like when able to see, so you can able to see the MongoDB image, like the Node.js, Redis. So and you can able to go down bit. So you can able to also find the Python, PostgreSQL, and Ubuntu software. So everything available over here in the Docker repository as a Docker image. Okay, as a Docker image. Why? Because let's say why it has been provided as a Docker image. Let's say you're the user. Now the user has an OS which is not compatible to the Ubuntu software, or let me say not compatible to the Python software. Okay. Now what happens? He can't able to use the Python software. Why? Because the system is not compatible. The OS is not compatible to use the Python software. What do you have to do? So instead of downloading the what may I say Python software inside that particular operating system, what that user can do something bad. The user can take this Python Docker image and run this Python Docker image to make sure that he can able to have his own Python programming, Python software in his system. Right. So this is the scale where Docker images has been done. There are a lot of things to be get covered, guys. Okay, so the you need to push it in another scale. Like you need to work on some other things, right? Why? Because nowadays those who are creating their applications either are going to be a full stack application or creating a full stack application integrated with machine learning, full stack application integrated with cloud computing, any other things. What they do actually is that they will dockerize their application instead of making it as a public and making sure that available inside a local host. What they'll do something, but they'll dockerize their application and save it as a Docker image inside the Docker containers. Okay, to make sure. Why? Because we can't able to predict everything. That's what I said in the beginning, right? We can't able to predict everything. The customers who are going to use this product may not have the system capability. Why? Because let me give you an instance. So if I'm creating what we say machine learning application, right? So the machine learning, a deep learning application which runs with visual data, right? It works with images, and I'm going to work with X-ray images, or medical healthcare images. I'm going to work with that thing. So the thing is, I need to have a GPU. My laptop is configured with GPU like NVIDIA 1650 Ti or GTX 1650 Ti, anything else. So I'm having those things in my hand. But unfortunately, the user is going to use my product from my GitHub repo. I've stored my things inside my GitHub repo. One of the user is seeing my repo and using the application what I developed. But unfortunately, he doesn't have the GPU support in his laptop. Now what happens? He can't able to run the application. And why? Because the application will run only if the GPU support is available inside his or laptop. So what can I do to make sure that it is sufficient for him to work on it? Instead of deploying the application as it is in the GitHub repo, I can push it as a Docker images stored inside the Docker containers to make sure that he can able to use the Docker containers and run the Docker container in his system to make sure it is easy for him to run the application what I did. So this is the pipeline where I want you to say today, right? Okay. So we started with like the Docker images. So where the Docker images are stored. The first thing, the Docker images are stored in public Docker repositories, where the public Docker repositories is available for everyone. Okay, it is public, where available to everyone around the world. And as I said, this is the public Docker repository and the Docker Hub. What I just stored, what I just shown to you, that is the public Docker repository where you can able to find lots of container images, and you can able to find base images for your OS guys over there. You can find Ubuntu, you can use MySQL, Node.js, Java, and you also see in Python, Redis, etc. is available. But instead, if AWS is gonna provide you if AWS is gonna provide you another private Docker repository. Why? Because if it is gonna be private, like if it is want to designate it for you, the user who's gonna create the Docker images, like private Docker repository, then we have some set of services to get work on. First thing, the first thing where you need to know, the first thing you need to know is that the ECR, that is the Amazon Elastic Container Registry. So the Amazon Elastic Container Registry is a private Docker repository provided by Amazon Web Services. You can use the ECR to store your Docker images, and you can run the Docker images with the help of Elastic Container Servers. Okay, so I'll show you the architecture in the next in the upcoming slides. So you can use Elastic Container Service to run the Docker images stored inside ECR, right? So this is what I've just showed. So how to run the Docker images in AWS? The first thing, your application, any application, what you have, you'll be creating as a Docker image. You'll be pushing it as a Docker image, right? After creating it as a Docker image, you will be pushing the Docker image into the ECR. That is the Amazon Elastic Container Repository. Amazon Elastic Container Registry, where Amazon Elastic Container Registry will give you the commands to run inside your system to make sure that how to store your Docker images inside your repo. So it contains both public as well as private repo, but more what can I say sophisticated. ECR works with private repo only. Now I've stored my Docker images inside my Amazon Elastic Container Registry with this ECR. Now I want to run that in my images which is available inside ECR. Now the next thing is I'll use Elastic Container Service, which is ECS, to run the Docker images present inside the Docker images present inside what can I say present inside the ECR. But you can ask a question. Let me say that the Docker image is nothing but an OS. Like let's have an Ubuntu OS. Okay, Ubuntu OS needs an infrastructure, right? It needs a particular infrastructure. Like it needs a baseline hardware, baseline networking protocols. Everything Ubuntu OS should have. So whether Elastic Container Service is gonna provide all this infrastructure is needed? Yes, it does. The Elastic Container Service, which is nothing but ECS, will give you the infrastructure is needed. Why? Because Elastic Container Service is being integrated with Amazon EC2 instances for the infrastructure needed for the Docker images stored inside the ECR, right? But you can also ask another question too. Do we scale from with the infrastructure needed with the EC2 instances? Why? Because it is a server which virtual service we needed to serverless. Yes, it is also possible. We can also move from server based EC2 instances to the serverless thing inside ECS itself. But there are lots of that's a service where we're going to learn in the next two upcoming slides, so please make sure to concentrate on that thing. So this is the pipeline, guys. Okay, whatever application you have, make sure to Dockerize it as in make sure to convert it as in Docker image. Now inside this Docker image, you will find all the things which is needed. So inside the Docker image, what you'll find is nothing but all the what they say software tools needed for your things. So what actually you can ask what the Docker images will contain. The Docker imager will contain all the software which is needed for them to install and all the other important things which is needed for the application to run instead of the what may say system capabilities issues. Okay, all the software tools needed for the Docker image to run, as well as all the other important things for the Docker images to make it compatible with the other systems. Okay, now this is the complete what I say architecture where we are supposed to work on. Like you have any applications, make sure to convert that as a Docker image, push the Docker image inside your Amazon Elastic Container Registry, which is ECR. Now you are supposed to run the Docker image stored in ECR, use ECS backed up with infrastructure needed. You can go with any number of EC2 instances based on the Docker image, based on the size of the Docker image, what you have, what is present inside Elastic Container Registry. And you can also have the load balancer over there and auto scaling groups attached with those things. You can just build the architecture as you like to. Right? Now, so what Elastic Container Service is all about? So I've said something about Elastic Container Service. So Elastic Container Service is a service which is used to run your Docker images from the what may say registry, which is ECR, right? So which will launch the Docker containers on AWS. And as I said, Elastic Container Service will need some infrastructure. Why? Because the Docker images which is being stored inside ECR might need some infrastructure, like might need some what they say networking or hardware, some other things he needed, right? So how the Docker how the ECS is going to provide the infrastructure? So ECS being integrated with EC2 instances in such a way that it will provision and maintain the infrastructure, what and all needed for the Docker images which is being stored inside the registry. And AWS will take care of starting and stopping the containers. You don't want to, what can I say, take a look don't want to burden these things, but because AWS will take care of your starting and stopping the containers. And as I said, it will have integration with application load balancer. Why? Because if the Docker image is an application which takes lots of server requests, so what happens? We need to get access with the load balancer, and more sophisticated, we should have an application load balancer which works with compatible layers of TCP/IP protocol. So why? Because I haven't covered the different types of what may I say load balancers. I've just said you the name, like the application load balancer, gateway load balancer, network load balancer, and classic load balancer. But when you go much delve into it. So you learn about what application load balancer is all about and why sophisticated for these things go. Right? So far, so good. Now, now, as I said, like Elastic Container Service, is a service which is used to launch the Docker containers on AWS. But and if the Docker images need some infrastructure, ECS is being integrated with EC2 instances, and you can scale up the EC2 instances about what amount of EC2 instances you need. But I also said, can we move from scaling up our EC2 instances into a serverless mode? Is there any other service which is available? Why? Because serverless is an advancing technology. Why? Because lots and lots of people are moving from launching their application in the server mode to a serverless thing, and they are trying to put it as a serverless. Why? Because the customers, like the users who are using the cloud, they don't want to care about the infrastructure. They don't want to provision. Don't want to focus on provisioning and maintaining the infrastructure. Do we have a serverless mode in Elastic Container Service? Yes, it is has. Yes, we have the Elastic, like what we say, it also have the serverless offering, which is called as Fargate, right? So Fargate is also used for launching your Docker images, like launching your Docker containers in AWS by taking the Docker images from the Elastic Container Registry. But only one thing is that it runs on serverless mode. Why? Because you don't want to why? Because you don't want to think about provisioning the infrastructure. Like, so without provisioning the infrastructure is nothing, but you don't want to take care about provisioning the infrastructure. Like, the Fargate will take care all those things what you needed, and you just want to make sure that it works in the serverless offering. And AWS just runs containers for you based on the CPU and RAM. What do you need it? And here comes the ECR, where the ECR is the registry, the private repository, a private repo given by Amazon Web Services to store your Docker images from the on-premises server. So it's a private Docker registry. That's where you store your Docker images. And you can make sure that if you store your Docker images inside ECR, you can either run the for what I say Docker images using ECS by scaling up the infrastructure, or you can also run the Docker images using Fargate by serverless mode. Right? So far, so good. So we talked about Docker. We talked about containerization, right? Well, because you might get into the list of services. Like, we talked about ECR, we talked about ECS, and we talked about Fargate, where the pipeline goes from your application, converted as a Docker image, stored Docker image inside the ECR. Now run the application, run the Docker image with the help of ECS, backed up with the infrastructure needed, with the scaling up with EC2 instances, or you can also run your Docker images with the help of Fargate as serverless offering from the, what can I say, from the AWS. So far, so good. So only one service I left over here in terms of containerization is called as EKS, which is Elastic Kubernetes Service. But I would say it is not needed for you for your, what can I say, for your cloud practitioner thing. But if it is needed, we can try to cover in the next upcoming classes if we have. Okay. So the first part is done. So next, what we're going to see is called as serverless. So yes, you have said about serverless, well, because Fargate is one of the serverless offering from AWS, which helps us to run the Docker images inside the ECR without scaling up your infrastructure, which is nothing but the EC2 instances. But so what actually the serverless is all about? Lots of people think, like what I say, that whenever I teach serverless serverless, right? So to the students, what they think is nothing, but they actually think that there is no virtual servers at all, right? We are not going to scale up the servers at all. But unfortunately, that is not the correct way of understanding understanding. What is that? You will be seeing the infrastructure, but unfortunately, AWS will take care about the, what may say, of provisioning and scaling up your infrastructure. You don't want to provision that thing. That is the difference between the server and serverless, right? Serverless is nothing but, you don't think that serverless is nothing but there is no virtual servers at all. There is no infrastructure at all. Not like that. There is infrastructure, but you don't see actual. You don't want to provision. You don't want to manually provision and scale up your infrastructure for your application needed. Serverless will do the automatic things which is needed. So this is what the basic thing what I want to cover, because most of the people, whenever I teach serverless in AWS, this will become another huge hectic for them. Is that the thing? Like, you don't want virtual servers at all? Not like that. So this is the way what you have to understand. So what is serverless? The basic understanding. So it's a new paradigm, like I would say. So don't want to manage the servers at all. There is no infrastructure at all. Don't want the infrastructure at all. and just deploy your code, just deploy your functions, just deploy anything what you have. Just deploy. Don't want to manage your infrastructure. Don't want to manage any networking, hardware, or EVS volumes, anything. Don't want anything you need. Just deploy. The word just deploy means a lot. You want to just deploy the code, what you have, just deploy the functions, what you're working on, just deploy anything what you have in your hand inside the on-premise. But you need to have a serverless offering, then it's a thing. So initially serverless, like when initially serverless has been integrated or termed as fast, which is a function as a service, which takes a function. Serverless is nothing but a function which provides you as a service. That function is where you don't want to provision any kind of infrastructure what you need. So one of the important service what we're going to see today is AWS Lambda. Why? Because AWS Lambda is the first and foremost service provided under serverless. Why? Because AWS Lambda is the serverless function. Like I would not say like it's a function as a service. AWS Lambda is the function as a service, which is a serverless offering. Okay, but nowadays it has been scaled up, like rather than only having it as a function, now it has been scaled up to databases, messaging, storage, etc. Right? So inside storage, why? Because we talked a lot about storage and databases, right? So we talked about S3. S3 is nothing but a serverless offering where you don't find any infrastructure needed for you to store the particular thing. And databases, DynamoDB, one of the important thing, Athena. So everything is a serverless offering. Now, instead of starting from Lambda, instead of having a function, now AWS has been scaled to deep, what can I say, databases. And what we are seeing in the end of today's class, we're going to see about the cloud integration concept, which is also having a lot of serverless offerings and storage S3. So that has been scaled to high, right? Now, this is what I want to see. But don't think in a different way. Serverless does not mean there are no servers. It just means you just don't manage or provision or see them. Guys, I would want you to, what may I say, if you are taking notes, please try to add this in your note. Why? Because this is very, very important. Okay. So if you are thinking in a different way, saying that serverless is nothing but a blind thing without any virtual servers, it's actually wrong. You don't see them, you don't manage them, right? You don't provision them for your application what you're building inside AWS, right? Fine. Let's see the first service in a serverless offering, Lambda. So Lambda is a function as a service, as I said in the beginning. It is a serverless offering, serverless offering. The Lambda is a serverless offering which provides you a function, sorry, which provides you a function which helps you to trigger some of the events which has happened inside your architecture. I'll try to show you one of the important architecture and also taken. And in this class, we have taken a lot of architecture, guys. We'll try to push it each and every architecture, and I'll also try to point each and everything where it runs and what actually happens over there. Okay. If there is any event happen inside your AWS, inside your application, sorry, not in AWS, inside your application, if any event has been happened in such a way that you are pushing your images, pushing your document inside S3, that's an event, right? Pushing, like, let's say, you are pushing your file inside your S3. So this is an event. So this event has been happened. This event will be triggered by Lambda, and this Lambda will have a function where this function will make sure that if anything happen, like if any event has been happen, I want to do the following use cases. Like the same thing, guys. What you'll write in terms of def inside the function. So what the function is a piece of code which will execute only when the particular condition has been executed. That is the same thing over here in Cloud 2. If any event happen inside your application, then the Lambda function will be triggered and it will execute the operation which is being stated inside the Lambda function. Fine. So far, so good. Now let's see what we have in this one. So Lambda, so we know about the basic understanding, right? Now, virtual functions, no service. As I said, it's a virtual functions. It has no service, land limited by time. It has very short executions, runs on demand. What you needed, you can do it as it, and scaling is automated, guys. Okay, but because if you add lot of Lambda functions, that is also easy for you. You can put n number of Lambda functions what you have. So let me compare with Amazon EC2, right? Why? Because Amazon EC2 is a server offering and Lambda is a serverless offering. So Lambda is a virtual functions where it does not need any servers to manage, but EC2 is a virtual servers in the cloud where, as a user, you will be provisioning what and all needed for what it all needed for the servers, and it will be limited by RAM and CPU. And there is no concept called limiting by RAM inside terms of Lambda, but because it's completely serverless and it is continuously running. In terms of Lambda, it based on demand. If you need Lambda service in that particular moment, you want to use that thing. So it is not being running entirely. It is not really being, running continuously. Only when the event is being happened, the Lambda will be get triggered. And scaling means intervention to add or remove servers. As we said, the scaling is not like we try to put auto scaling groups, but what we'll try to do manually in such a way that the auto scaling groups will work on that particular cases. But here, scaling is automatic, right? Clear? Guys, you need to know about some difference between a serverless offering. One of the important pioneer serverless offering in AWS, which is Lambda, and comparison to EC2 will be in what may say will give you an overview about how serverless offering means to you. And more on AWS Lambda. So it is easy pricing. Why? Because those who are going to attend your what can I say Elastic or cloud practitioner certification, these numbers are very important, guys. Okay, and moreover, these numbers will play an important role. And when you have started working inside cloud, you need to know about everything in advance. Why? Because when you go more than one, what can I say, 1 CR. So like the free tier of 1 CR AWS Lambda requests. If you go more than 1 CR Lambda requests, then you have to pay for the cost. And if you go 4 lakh gigabytes of compute time, more than 4 lakh gigabytes of compute time, then you're supposed to pay for it. So when you started using cloud as a solution for that, a solution for your architecture, then make sure to know the numbers in advance to avoid the what may I say pricing, right? So it is easy pricing, pay per request and compute time, pay for on demand. Like why? Because whenever it is needed, it will be triggered. And free trial of 1 CR AWS Lambda requests and for 4 lakh gigabytes of compute time. I think so. 1 CR AWS Lambda request is more than enough for all the applications what they're running. So they don't want to pay much. Actually, they don't want to pay. And one of the important thing is Lambda has been integrated with all the whole suite of AWS services. Okay, so it has been integrated with EC2 if it is any instance happen, any events happen, S3 databases, etc., etc., and etc. And it's event driven. As I said in the beginning, the functions will get invoked by AWS when it is needed. Like whenever a function and an event has been happened inside that thing. So why? Because if your architecture is an event driven architecture, okay, EDA, which is event driven architecture, then that event driven architecture events will make sure to possess these AWS Lambda to trigger the AWS Lambda such a way that, yeah, this event has been happened. Make sure to run that particular function, right? This is what the pipeline, what you need to know. And integrate with many programming languages, guys. So the function what you're going to write inside AWS Lambda, you can write with any programming language. And there is will be easy monitoring through CloudWatch. Why? Because you have not seen CloudWatch yet. So CloudWatch is a cloud monitoring function, cloud monitoring service, which helps us to make sure to what may I say monitor the services running inside the AWS cloud. One of the important offering from AWS is AWS CloudWatch, and easy to get more resources per functions and etc. All those things. And these are the language support provided by Lambda, which Node.js, JavaScript is provided, Python, Java 8, C Sharp with .NET Core, Golang, C Sharp, PowerShell, Ruby, and you can also have any custom runtime API, which custom supported, example, Rust, and Lambda container images too. So if you want to have any container images to be pushed inside the Lambda function, that is also available. So where you have to do that thing. So the container image must implement with the Lambda runtime API, and as we seen in the containerization concept itself, the easiest of targets should run their container image, and that container running part should be deployed inside the Lambda runtime API. There so far? Okay. This is what I try to put you. Let's see some sample architecture. So this is a serverless combined creation architecture. Let's see. Now let's get an instance. I do have a new image. Now I'm going to push this new image inside S3. Okay, this is an S3 bucket. Okay, this is an S3 bucket. I'm going to push this new image inside S3. Now, this is one of the event that's been happened. Yes, but because I'm pushing an image from on-premises to the S3 bucket. right? From on-premise to the S3 bucket. So this is one of the event has happened. Now what happens is over here is, I think when event has happened, then this event is being triggered to the AWS Lambda function. Okay, this AWS Lambda function will create a thumbnail. Why? Because what the function states actually is that this Lambda function will create a thumbnail. This thumbnail, what is going to do is nothing, but I'm going to do two important things. The first thing, I'm going to put a new thumbnail in S3. Like the things you can able to see, thumbnails here, the size of the image has been decreased, right? I'm going to push the new image inside my S3. And moreover, one more important thing doing inside Lambda function is that I'm going to store all the metadata inside DynamoDB. Okay. So what happens is that whenever I push a new image in S3 bucket, the Lambda function will get triggered and will create a thumbnail where that thumbnail will be doing two important operations. One, reducing the size of the image and pushing into the same S3 bucket and storing the metadata of the information inside the DynamoDB. Okay, this thing, like you can ask us whether we are gonna do this thing, whether we are gonna do this thing. No, these things are automated where we're gonna write a function inside Lambda in such a way that if any new image has been pushed inside Amazon S3, do the following: reduce the size of image, push it inside Amazon S3. Take the metadata about the image, push it inside DynamoDB. We're gonna write a function. Whenever the event is happened, this thing will be happening automatically. Okay, so this one thing I want you to show you today, and pricing, guys. So I think so I've already said, and this is one of the thing you need to know in advance, like for paper calls. So first, for 1 CR requests are free, as I said at the beginning, and the paper duration, 4 lakh gigabytes of seconds of compute time. You need to know about it and need those numbers. Okay, I don't want to state these numbers. I'll share the PPT. Make sure to get to know about these numbers very clear. Let me say, don't take it more bluntly, but because when you're working in terms of serverless, you need to know about these numbers. If you go more behind it, you need to pay for that thing. That's right. For pricing, you need to know these numbers. Okay. Now, let's see for the next service. So first service what we have seen today is Lambda, which is nothing but the serverless one of the the pioneer of AWS serverless offering. Second service, what we're going to see today is called as Amazon API Gateway. Let's say, so this is the thing what they have taken so far. Let's see. So here is a client. Client uses REST API. So you guys know about what API is all about, right? So it's an application programming interface which is used to connect two of your applications at once. Now, so I'm going to do a create, read, update, delete operation inside DynamoDB if the client is going to give me any request to the DynamoDB. What instead? Since it's not going to give a direct instance, it's going to give us the REST API. So I need to have a gateway in such a way that it takes the REST API and provides my proxy request to the DynamoDB. So that API gateway will help me a lot to take this REST API and provides my proxy request. And what happens whenever the proxy request is upping from the API gateway, I'm giving in another Lambda function to trigger the create, read, update, the CRUD operation inside DynamoDB. So this is all about it. So it's a fully managed service for developers to easily create, publish, maintain, monitor, and secure your APIs. If you're working with any APIs, Postman APIs, or any kind of other third-party APIs, to integrate that with Amazon Cloud Services, then API Gateway is one of the things which takes a REST APIs and provides you the proxy request needed for these services you need to create, update, or delete. Right? And it is a serverless and scalable. As I said, it supports RESTful APIs and supports WebSocket APIs, supports for security, user authentication, API throttling, API keys, monitoring, etc. Right? We can work with any kind of API styles. It can be any kind of third-party APIs like a REST or RESTful and WebSocket APIs or Postman APIs, etc., etc. So it will work with any kind of. So this is the second. Batch. So far, so go, we learned about some of the serverless service, right? So third service here today, we're going to learn is AWS Batch. Batch is nothing but if you want to run your whole scale application. let's say I'm writing, and let's say we are having a machine learning application. But unfortunately, what happens? Nothing, but it has sequence of steps to be followed. One after this, one after that, one after that. Like let's say, so it has sequence of application. Like first step number one should be completed. Step number two get completed. Step number three, four, five, etc., etc. And step number seven is a a checking part where seven is being approved. Output will be produced, or else it has to go to step number four and it has to do the cycle operations. So it is in what we say, it has been integrated in such a way that it works on terms of batches. Batch one should be completed. Secondly, the batch two, go for the batch three, for batch four, for batch five, etc., 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 to batch seven. And if it has been there, it comes to batch four. So to make sure that this cycle, like this kind of batch oriented application, batch oriented scheme should be available inside AWS. That the one of the offering by AWS is called as AWS batch. Okay. And what the example I've said, right? So the example like the machine learning in terms of AWS batch, I've written a blog on that. I'll share you in the group. Try to watch that because I've clearly explained what batch is all about and providing an integration with machine learning, right? So you'll understand both what may say, how to scale up your machine learning jobs inside AWS batch will be more helpful for you, right? So fully manage batch processing at any scale, and you can run almost 1 lakh of computing batch jobs. Okay, batch jobs on AWS. And as I said, a batch is a job with the start and end. Like what me say. So first job, it has a starting operation and it has an ending operation. Okay. Once the batch one gets ended, batch two will start it and batch two will get end. Once the batch two gets end, batch three starts and goes on. So this is what their complete pipeline will be going. Okay. So each and every batch is a job where it has both start as well as end. Okay. And batch will dynamically launch EC2 instances or spot instances needed for the application what you are scaling it up. Okay. If your first batch, like the first batch of your application needs an EC2 instances, then they will dynamically launch the EC2 instances, spot instances needed for that particular batch, the particular job. And batch provides all those things, guys. So batch provisions the right amount of compute or memory, what it is needed for you, and you can submit your batch inside the batch job. And what other thing is, I think so. You guys learned about scheduling, like CPU scheduling in terms of operating system. If you're not aware, I'll also say share you in the next. 1 second, just give me a minute. What you'll do is nothing but in terms of CPU scheduling, right? So in CPU scheduling is that you schedule your jobs, you schedule the process what you have. Those process you'll set the priority of the processes like P1, P2, P3. P1 has highest priority than P2, P2 has highest priority than P3, and goes on. So fortunately, what CPU will does is that you will not run the process, right? What CPU will does nothing, but based on the priority, it will run the most prioritized process first. Like P1 will be executed first, then P2, then P3 goes on like that. The same thing in terms of AWS tab, AWS batch two. What you'll do is nothing, but you will have all those batch jobs in your hand. You will schedule the batch job, and you'll submit to AWS, and AWS will take care of the rest based on the what they say priority what you have on the batch jobs. It will be executed, right? And batch jobs are defined as Docker images and runs on ECS. I want you to take a note on this thing. Batch jobs are defined as Docker images and runs on ECS. Okay, but because since it is a serverless offering, and there are a lot of what can I say, an application might have lot of jobs inside it. Okay, lot of batch inside it, and each and every batch might have a lot of other configurations too. So we can't able to scale each and everything. It will be a tedious job for us. Instead, what we can do is something but one of the best offering that batch is being integrated with ECS, where you can define your batch job as an Docker image and you can run on ECS either with Fargate or either with EC2 instances that you wish. And helpful for cost optimization and focusing less on the infrastructure. So this is what, guys, I wanted to give an overview about it. So these are the states of job body, the states of the what can I say, These are the states of the job. What do you have? Just give me a minute. I just got stuck. Sorry, guys. I just got stuck. Okay, so this is the states of the job. What I just saying in the last line, right? But because whenever you schedule your job, you'll push the job inside AWS batch, and the batch and AWS will do the remaining. So how it does? Okay, so this is all. So I've taken this picture from AWS. Why? Because when I learned like the AWS batch, I've seen this diagram. It looks fascinating for me. That's why I just took this picture. So what will do something better? You will have your AWS batch. Like you will have your job. That is nothing but a batch. You will be submitting, and that job will be in the state called as submitted stage. Now, whether we need to, since the job is being submitted, we need to run that particular job. So, but unfortunately, AWS batch is running currently running another job inside it. So, what happens? The submitted job will be going to the pending state. Like the job which is present inside the submitted state will be going to the pending state. Why? Because your job has dependencies. Why? Because other dependencies need to run. Okay, other dependencies need to run, or else this job, if we want to run that particular job, it has some of the priorities to be run first. Okay, let me give you an instance. Like if I'm going to run a function, that function needs both front end containers, front end things, and front end things first. So I need to run the front end things first. Then one day I can go for the function execution, right? So till the front end execution, I need to make sure that particular function should be available inside the pending state, right? So once it has been pending state, all the runnable has been done. What happens? Nothing but this function will get executed in terms of runnable state. So it will go to the runnable state, and your job will be evaluated. And who will run this job? So you will have a scheduler. So the same concept what you have in OS, guys. Okay, in operating systems, if you have learned if you have learned in your college days, so the same thing will be coming over here. The scheduler is the one where he will run the job by scheduling the job, right? So the job which has been in the runnable state, the scheduler will make sure that it will evaluate by the scheduler and will ready to run. Now it is in the runnable state. Now what I have to do? I have to start the job and I have to run the job. Now it has been running. Okay, it has been running. So now the job can be what can I say? Ended with two important states. It can be succeeded or it can be failed. So it can run with it can finish with the exit code 0, which is an succeeded state, with exit code 0, which is succeeded state, or the non-zero exit code, what can I say, exit code in such a way that no, your job has been failed. There is somewhat discrepancies in your job. You are supposed to take care of it. So this is how AWS batch will run. You will define your job, you will schedule your job, and AWS will take care of all those things in the rest. And this is how the states of the job will be. What can I say? Will be moving from one state to another. You'll be submitting first. Make sure that it has any other priorities. The priorities will be in the runnable stage, and until that particular job will be in the pending state. Once all the priorities run, we'll move that particular job from pending state to the runnable state. Then we'll start it. Then we'll run the job. And once the job gets completed, maybe it can be succeeded with an exit code 0, or maybe failed. It has some lots of discrepancies. Then we'll be having the non-zero exit code. So this is what AWS batch is on. Now, very important thing. What the difference between batch versus Lambda? Okay, Lambda has a time limit, but because we also said in the beginning, like it has almost 1 year of request, and with some kind of time limits we have seen. I'll show you where it is. Yes. So yes, the paper duration increments of 1 microsecond, and based on that, per month you have 4 lakh gigabytes of seconds. For 1 gigabyte of RAM, if the function is a 1 gigabyte of RAM, it has 4 lakh of seconds, and for 128 megabytes of RAM, you'll have what can I say, three C to 32 lakhs of seconds we'll be having. And after that, dollar 1 rupee, like sorry, $1 for your 6 lakh gigabytes of seconds, right? So after that, like after scaling up to 1 gigabyte or 128 megabyte of RAM, after that you'll be having your $1 will be charged for every 6 lakh gigabytes of seconds. So it has been having some limited space, right? So it has been having limited time capacity, what we are saying. So it has time limit and limited run times, what I just said. Limited temporary disk space, 128 megabytes, 32 gigabytes. Only that kind of disk space are remaining, and it is a serverless. Okay? And it's serverless. But in terms of batch is nothing but no time limit at all. It doesn't have any time limit at all. And we can run anytime as long as it is packaged with Docker image. Why? Because as I said, batch, if whenever you're creating a batch job, those batch job will be processed as a Docker image and you'll use ECS to run the particular Docker image, right? And rely on EBS instance store for disk space and rely on EC2, that is EC2 guys, relies on EC2, which relies on EC2 and ECS, right? EC2 and ECS that can be managed by AWS. Okay, but you can also ask, you have said that batch is a serverless, but you are saying that it has to rely on EBS instances or relies on EC2 and things. Very important offering. ECS ECS don't can't like what may I say. Containers can also run with Fargate instances, right? With the serverless offering. So that's where batch is also one of the serverless offering we can able to consider. But batch is a serverless. You don't want to scale up for EC2 instances. Okay, batch is serverless. But whenever running a job inside your AWS batch, the job will be processed as a Docker image that will require ECS to run your Docker images. Right? Okay. So I think so. This is the last service. So the last service in serverless is Lightsail. Okay. What is Lightsail? Lightsail is that, let's say, if I'm going to create, if I'm gonna, I'm a newbie. If I'm a new beginner to the AWS Cloud. Okay, if I'm new beginner to the AWS Cloud and don't know anything at all, like what is EC2 or anything, like I'm very much scared about my cost. Okay, why? Because for the EBS instances, I need to scale up more, and for Lambda and for databases storage, I need to scale up. I need to what can I say? Worry about these things. I need to worry about these costs. Do we have any other platform where I can able to easily learn about AWS Cloud with less cost? Then that is nothing but your Lightsail. Amazon Lightsail is nothing but another platform, which is a serverless offering platform, which helps you to create your own applications, like create your own virtual servers, databases, etc., with lower amount of cost. Okay, so virtual servers, storage, databases, and networking. As I said, it is low and predictable price. Okay, you don't want to what they say, it's been a very tedious pricing, so I can't able to move to the cloud. So with the Lightsail you can do it, right? But as a beginner you have to start with Lightsail. Then when you get into much more sophisticated networks, then you have to move to the AWS cloud. Okay, and simpler alternatives to using EC2, RDS, ELB, EBS, and Route 53. Route 53 we have not seen yet. It is a CDN service, the content delivery network service, which provides you an DNS name for your thing. I'm just giving you one line about Route 53. And great for people with little cloud experience. And this is what the use cases. You can run your sample applications with the templates with LAMP, Nginx, MeanStack, and Node.js. You can also run with the MeanStack what you needed. And with Word websites, like with the templates for WordPress, Magento, Plesk, and Joomla, so which you have your websites, you can also run with Lightsail for low and predictable pricing. And it also has devs and test environment. It will have both developer and testing environment, which helps you to go ahead with things. And as high availability, and I want to make sure that it does not have any auto scaling. Okay, it does not have any auto scaling, and with limited with AWS integrations. We can't able to integrate a lot of scales over here. It doesn't have much integrations over here. Right? Okay. Before moving into cloud integrations, I would like to show you the services what we have seen so far. Fine. So I'm inside my console home. Let me provide you another thing. Okay. First, let's put my lights in. I'll show you how Lightsail looks like. So this is how your light sail will look like. Okay. So can able to see is in another platform which is more sophisticated, more easy for us to make sure. So you can create your instances, guys. Okay, you can just go ahead, create your instances, and the thing is, you do have your cloud shell. How your what may I say? How your how your management console will look like the same. Like you can able to see, instance location is Mumbai with platform whenever like the same thing is will be available inside your EC2 console. So I'll just show you how EC2 console will look like when you're creating your instances. I'll put it in instance and let me launch an instance. Okay, so can you able to see? I'll show it in another page itself. Okay, so this is how can you able to see. First, you'll giving you your pick your instance image, which is nothing but your Amazon Vision image, like the same thing which is available over here. And the instance type, you'll take the blueprint whether you need WordPress or measure. So, but here instead of having a blueprint, you can also take only OS Linux 2023 or Linux 2. They're also having the same thing. Come back down when able to see the SSH key pair, instance pair, where you need to take about the instance plan, like the type of instance plan. We said about the key pair which is needed for your login, and go back. You can identify your instances what you have, number of instances what you have, and key value tags. You can just create your own EC2 instances. Okay. Oh, can't able to see my both the screens, right? Guys, can you able to see my both the screens?
Single screen is visible.
Single screen. Okay. In a minute. Can you now? Now?
Yes, we can see it now on the screen.
Okay, sure. So
Both.
sorry, guys. Sorry. I have not seen that thing. Okay, so this is how it looks like. So this is light sail. Right hand side is a light sail. Left hand side it is an EC2 instance launch platform. So here, can able to see the same launch instance portal is here. It is also the same with Amazon Mission Image. What you're gonna try to use, and you can select your blueprint. What your choice with app. With OS with application or only OS it is needed. And the OS maybe have different versions, different flavors. You have Amazon Linux 2023, the next two Ubuntu, Debian, and FreeBSD. Anything you can just do. And you have the SSH key pair where you can take it. As I said, SSH, which is used for launching your EC2 instances from your on-premises thing. You can also use that thing. And you can choose your EC2 instance plan. You can able to see the pricing. For first 3 months, it is free. And based on about the usage, you need to pay for the time and identify the instances, number of instances you need, and you just create instances. But in terms of EC2, when you come back here, you have to give the name, you have to create application, and you have to choose the instance type. As I said, T2.micro is a free tier eligible, and the network settings. You are supposed to create a security group which allows both HTTP or HTTP traffic. That's your wish. You can put your own existing, you can put your own security groups, which is nothing but which has the specified inbound and outbound rules. And going with the configuration type and advanced summary, that's it. So I'm able to see that it actually both are same. But thing is, Lightsail provides you a compatible platform and it also provides easy and predictable pricing. You can just predict your pricing as quick as advance. As I said, go ahead. Only for the first 3 months it is free. Then for that thing you are supposed to pay. So you can able to predict your pricing at ease as you can. Okay. So that's what the Lightsail has been used. Okay. I'll show you another. Okay. Mm, let's check Lambda. So as I said, Lambda is a serverless offering. Okay, so serverless function offering which provides it's a function which will be triggered if there is any event has been happened. Let's create a function. Okay, I'll take it from the scratch. Like I don't want to have it as a blueprint or I don't want it as a container image. I also said you can also have it as a container image, but I'm going to create from scratch with a simple hello world application inside it. Okay, let me create a sample lambda function as my name. Sample lambda. In the runtime, what I'm going to give is Python. Okay, I'm very much comfortable in Python, and you can able to see remaining everything I left it as default. You can also do any other things like you can enable the tags to make sure to provide an identity to the function what you have created. I can also enable your VPC, a virtual private core for your private networking. So I'm not going to do that thing here. So I'm going to create an example Lambda function. Takes much time. Give me a minute. Okay. Now the Lambda has been created. Right. So this is how the diagram will look like. This is the template. This is the what may I say the cloud formation template. We haven't learned about cloud formation. We'll try to put it over here. And within the diagram also you can help. And this is how your template function looks like. Can you able to see hello from Lambda? And these are the environment variables. You can just test and you can create any event over here. I'll show you how to do it. So this is the Lambda function and which is being created. And you may able to see it is a Python code. Okay. Now, how to work on it? I'm going to add a trigger. Okay. Add a trigger. Add a trigger is that you have list of bulk of applications what you have from AWS IoT, from CloudWatch logs, from S3. From S3, you are supposed to provide a bucket name. And what is the event type? Event type will a very important thing. If I'm going to put any all object created events, if you create an object inside S3, this event will be triggered. Okay, the Lambda function will be triggered, and this Lambda function you can write the function code to make sure to happen, and all the other things are same. Clear so far? So this is how the Lambda will look like. I'm not going to create it. Why? Because I don't have anything inside my S3 bucket. We'll try to do it in the next consecutive in the other things too. Now let's show you batch. So batch is a fully managed batch processing at a scale, as I said in the slides itself. So let's get started. Now we are supposed to choose your orchestration style. As I said, you can either choose your EC2 instances. As I said, it depends upon EC2 instances, but we now Fargate right now. Fargate is a serverless offering which helps us to run your EC Docker images, the batch images, what we have. Okay. And you can create a computing environment, what you push, like the VPC, subnet options, the security group, what you have. Okay. The very important thing, the default things has been created, like the default VPC and the default subnets within the VPCs and the default security group. And you can just create the own name. I've been putting it that as default thing. And now we're going to create a job queue. Besides the job queue, the jobs are being posted inside. Okay, let me provide a priority as one from 1 to 100. You can just give. I'm going to be providing as one. And this is the timeline execution where you may be able to see. This is a container configuration. And can you able to see? Can you able to see the ECR's what can I say? The address. This is the ECR address where the what can I say? The Docker images will be stored, which is nothing but the jobs images, jobs Docker images will be stored inside. And these are the environment configuration types. So to just show you how it works, I just giving you an overview how the console will work. The same thing when you started working with AWS job, it will look like. Okay. So far so go. Right. So now let's get into the part of cloud integrations. Right. Now let's get into the part of cloud integration. So cloud integrations, right? Let's say I'm going to integrate with cloud. As I said, that's what the major goal about all the cloud developers, right? If I'm working with some kind of application, I want to integrate with cloud. Okay. So it can be both two ways. One is synchronous. That is, he's the one who's going to buy it. He's going to one who's going to ship it. There will be a direct integration between the buying service and shipping service. Application to application. I'm going to connect with application to application. Okay. Can be asynchronous too. That is application to queue, queue to application. Why queue is being given in such a way that there might be a lot of buying services. Okay, there may be a lot of buying services which has to get connected with the shipping services. Okay, so at one go, we give all the buying service to the shipping service. Shipping service will get demolished, right? It might get damaged. Instead, we need to provide a queue in such a way that those who comes first will be given much priority. That means you, as you know, queue is nothing but first come, like those who those who come first will be given priority first, right? The first come first serve. Okay, first come first serve, FCFS model, right? So those who come first will be given priority first. So that's the way queue has been given. So there are two different types of communications within the applications, right? One is going to be synchronous way, where application is going to directly connect with another application. There cannot be asynchronous communications in such a way that lots of applications will be connected with some server kind of application, right? So for that, we need to attach a queue in such a way that those who come first will be given much more priority. Okay. So when we start deploying an application, they will inevitably need to communicate with us. So there are two patterns, as I said. Okay. I wanted to show you one more thing. In terms of synchronous application, that when the buying application is being directly communicated to the shipping application, one kind of biggest problem we may occur. That is, let's say if I'm gonna have one more buying application, another more buying application, which gets connected with shipping service. Unfortunately, what happens in such a way that the connection between one of the buying service to the shipping service has been distracted due to some what do I say invisible unconvincible miscommunication. The integration between one of the buying service to the shipping service has been dominated or distracted. Unfortunately, what the other buying service will think is that, oh, when we try to communicate, when one of my other co-partner tried to communicate with the shipping service, he got distracted. Well, the same thing will be happening to myself and to the other customers who are trying to integrate with shipping service. They will think as like that, and to make sure that they will stop the entire communication at all. This will lead to a biggest problem. Okay, so this will lead to a biggest problem. When able to see, this thing will be demolished, this thing will be distracted. So fortunately, these are all not distracted. But what happened? One of the buying service has been distracted. They think that if we also communicate with the same shipping service, it might happen too. So what happened? They'll disintegrate, like they'll not communicate with the shipping service. This is one of the biggest problem to get control. That's why lots and lots of right now the application integration, like if they want to integrate with the cloud, what they'll do something that instead of directly integrating with cloud, they will have an intermediary option which helps us to integrate with shipping service, which is nothing but a queue based model. There are a lot of services to go ahead. Okay, so as I said, if there is a sudden spike or traffic, what if you need a suddenly encode 1,000 videos, but usually it is 10? That's why I said, right? Here you go. You are supposed to decouple your application. You are supposed to split your application into chunks, and those chunks will be pushed inside the queue. Does AWS has any offering for queue-based models? Yes, it does. So SQS, the simple queue service, is a serverless offering provided by AWS for providing a queue-based model to the buying services. And this is based on queue model, right? If you want any, what can I say, no, name node models for publisher subscriber model, that is PubSub model is nothing but publisher subscriber model. If you don't know, please go ahead and go and search up through Google what publisher and subscriber. It is very same like what can I say, producer and consumer problems, like the same problem what you say as like the same model what you see in your day-to-day activities. But there are a lot of communications types you need to know that. So go ahead and watch. And that is SNS, which is simple notification service. That is, from one application you need to notify all the other applications what you have, either through email, either through SMS, either through any other events, etc., etc., etc. And Kinesis. Kinesis is used for real-time data streaming model. Let's say I do have an IoT service which helps us to take the real-time data of the agricultural land, right? So if I want to process that real-time data inside my AWS, I need to have one service which helps in integrating that real-time data streaming model to my AWS cloud. And that the name of the service is called as Kinesis. And Kinesis has lots of offerings, but you just want to know about the basics for cloud practitioner level. Basic is simple. Okay. And these services can scale independently from our application. Okay. Let's get into SQS. What SQS is all about. Amazon SQS is a simple queue service. Like, let's say, this is what are the diagram I've just chosen for you. When I have a lot of producers, right? Lots of producers, maybe n number of producers we have. Okay, they have to send messages to the consumer, and the consumer want to retrieve back to the producer. There will be mutual communication between both producer as well as the consumer. Let's take it as a producer consumer problem. Okay, let's take it as a producer consumer problem. Let's say I'm going to send messages to consumer, the consumer is going to get sent back to the producer. Unfortunately, there are a lot of producers, lot of consumers, and one producer want to reach more than two consumers at a time. It may be a huge, what may I say, tedious thing. Why? Because lots of traffic. If any one of the traffic gets distracted, all the other things will. The traffic is being distracted. We don't want to use this pathway. It will be a very tedious thing. Instead, what I can do something where I do have an integration with SQS queue, where the SQS queue will maintain a queue. This queue, let's say, I'm going to give numbers to the producer, which is 1, 2, 3. One access to the queue first, three access to the queue next, two access to the queue at the last. So first of all, I have to prioritize the producer number one, and I have to give access to the number of consumers what the producer is being needed. Once one has been done, one has been completed, one will go off, and I have to allocate the consumers for producer number three. Once the producer number three is done, it has to move out, and finally I have to allocate the consumers which is needed for producer number three. So this is the way where the applications, where the producer application integrated with the consumer application or any two application integration in such a way that lot of application calls which is being arranged inside the inside the integration, where SQS will help us a lot to make sure to prioritize which application takes up the call first, right? So SQS is a standard queue, and SQS is one of the very oldest service offering by AWS, but because cloud integration is the first thing where we come to mind, right? When we are talking about when we are learning AWS cloud. So SQL cloud, we need to know about that first. So that's why SQS is the first and very most oldest offering, more than what may I say over 10 years old, and it's a fully managed service used to decouple with application, scale from 1 messages per second to 10,000s per second, right? So you can be able to scale up 1,000, like 10,000 messages per second. You can go ahead, right? And default retention of messages 4 days, maximum of 14 days. That is, if we go more behind than 14 days, okay, figure more behind than 14 days, it might reach to another other path. Okay, so if inside the queue, inside the queue, the what may I say, the message has been leading to 14 maximum 14 days, then we need to remove that message from the queue itself, because it has been there for a long period of time. So limit how many messages can be in the queue, can be having n number of messages in the queue, and that's why I said messages are deleted after they read by the customers. So it also have low latency, where you can have the what may I say, publish and receive will be less than 10 milliseconds. What we have, the delay what will appear inside the thing will be very low. Fine. So this is the what may I say, SQS, which helps you to integrate your publisher subscriber model, or it also integrate your producer consumer model in such a way that lot of what may I say, requests has been given to the what may I say, producer one, which makes sure that we need to arrange those what may I say, integrations based on the priority, based on the FCFS, first come first. Clear so far, SQS. Now, Kinesis, as I said, if you are running an IoT service, if you are running in any IoT model, then that IoT model will give you an real-time data. Like it gives you the temperature at one particular area, and if you move from one space to other space, you'll be having another data. So it will be a real-time data. So we need to integrate this real-time data into an AWS cloud. So do we have a service? Then that service is called as Kinesis, which is real-time data processing, which is a managed service so not only to like what can I say, Kinesis has almost 4 different offerings, guys. Okay, I will just mention you that thing. We're also going to see the same thing, but as I said, these 4 offerings are not needed for your AWS Cloud Practitioner level. For your understanding, I'm trying to give you the name of the service, so make sure to understand that. Okay, first thing is all about Kinesis data streams, which helps us in non-visual data like the IoT's data, or IoT data, which takes up the temperature or pressure, which provides you the data as a thing, right? So to stream your data inside an AWS cloud, Kinesis data streams is the thing. Kinesis data streams is nothing but the one of the important offering. Second thing is Kinesis video streams. Okay, Kinesis video streams is being integrated with AWS ML machine learning, which makes sure that if you have any real-time video streaming models, you can integrate with AWS Cloud with the help of Kinesis video streams. Now, the data has been pushed inside AWS Cloud. We need to analyze the data, right? Because simply don't we don't have any sense to push the data inside the AWS Cloud. We need to analyze the data. Does Kinesis have any kind of offering to analyze the data present inside AWS Cloud? Yes, that is Kinesis data analytics, which can help us to analyze the data which is present inside, which is being streamed inside through Kinesis. Okay, Kinesis data analytics. And finally, I want to give you one more thing, which is Kinesis data firehose. Okay, Kinesis data firehose is one of the ETL service which tries to extract the data from the Kinesis, transform it, and load it to the destination service what we are trying to push. But you might ask, in the last, in the last class, I think so, we also seen one more service which is called as AWS Glue. Glue is also an ETL service what we have. But what is the difference between AWS Glue and AWS Kinesis Data Firehose? Okay, so please make sure to put it in a whole mind that AWS Glue works for data which is being scaled at warehouse. Like if you have a lot of data, like if you have a large amount of data, then go ahead use AWS Glue. But if you have any short stream of data within what can I say real-time data streaming model, then if you want to extract it in a real-time data streaming model, real-time streaming data, and transform and load it to the other way the service can able to use it, then go ahead with Kinesis Data Firehose. Okay, so these are the offerings what I just said, and it has been listed over here. So this is how the Kinesis workflow will be happening, guys. As I said, you'll have your quick streams, which is happening inside your on-premises, and you also have your IoT devices and the metrics and logs, which is available. You may also have a CloudWatch logs, CloudWatch metrics, or you can also take your mobile logs too. Okay. Do you want, so there are nothing but the real-time data. You want to push the real-time data inside your what can I say? Either you want to store the data inside S3 bucket or Redshift. What do you have to do? You'll use Kinesis streams, which is under Amazon Kinesis, and you'll analyze that using the data firehose. You will extract the data, transform the data, and load to the particular destination. Why? Because S3 needs object data to store. So it will, what can I say, transform the data into an object and store inside S3 bucket. And Redshift needs data to be clusters. What happens? So it will load to the particular data format how Redshift will store. So it will store inside everything. So this is the Kinesis workflow where you need to know. And I've taken one more example where I've learned this thing. So I've taken from AWS friendly. So this is the anomaly detection architecture with Kinesis Analytics, where you're going to analyze you'll be pushing your data, and that data will have some anomalies. That anomalies will be detected with the help of Kinesis Analytics. How to do it? Let's see. So your data will be present. I'm sorry, I'll just change my color. Okay. Your data will be present inside Redshift. Why? Because since we need history of data, a lot of history of data, made able to scale or what may I say, data warehouse and push the data inside Redshift. Or else we can also have it inside S3 and we can analyze through Amazon Athena. Okay. What happens? Nothing but of all those things is working inside EC2. Okay. All those things are working inside EC2. Why? Because each and every data which is going to work inside my particular workflow should need a virtual server. This is somewhat a real-time flow. This is somewhat the real-time flow. Now I have to take the data and I have to analyze and to make sure that is there any what may I say, is there any other anomaly has been detected on. With the help of Kinesis streams, data streams, I'm going to integrate with it and I'm going to write a code, which is an SQL query with the help of SQL query with the tables which is being stored inside Redshift. I'm going to analyze it and I'm going to check if there is any anomalies been detected or not. So with here they have used one important what can I say algorithm called as random cut forest, the RCF algorithm. I don't want to explain you the algorithm. The algorithm will go for almost 2 to 2.5 hours of learning. Because if you want to learn for machine learning practitioners, you need to know the basic algorithm which is available inside AWS. But I don't want to go ahead with that thing. So random cut forest is an algorithm which has been used with the help of the using analytics will be trying to run over that, and with the help of Firehose, right? Firehose will be transforming the load into S3, or we can also store inside EES, which is nothing but MQ services, Kibana, and with the quick side, we can also analyze the anomalies which has been detected with the help of the spikes. We can make sure to put it over there. So this is one of the important use case, like a real-time use case, which can help you to get to know better about Amazon Kinesis. Okay, SNS, which is the simple notification service. Simple notification service, as I said, if you want to send your if you want to send email notification or send your message notification to more than one consumers. Okay, let me to see. This is a buying service. I have to sorry. Is a buying service. I have to send email notifications to more than four, or you can able to have a queue over here too. Yes, it is also possible. We can also have an SQS queue over here. So this is direct integration, and with the help of SNS topic, we can also integrate the thing. So what is the difference between direct integration and what is the difference direct integration and with the PubSub model what we have? Direct integration. That's why they said if there is any distraction happened over here, or it might lead to any kind of problem, right? So what can I say, to relieve from that problem which is being characterized through the direct integration, we are trying to use the SNS topic, which is one of the important service in what can I say, AWS. Okay, so SNS is an event publishers where you can able to make sure that if you want to send notifications, simple notification service, you want to send notification based on the topic what you created to the subscribers which is being subscribed to the SNS topic, we can do it. And they are what may I say even subscribers. Why? Because based on if any event has been happened, they will be subjected to in such a way that yes, this event has been happened, and SNS, yes, this event has been happened. I have to push to all the what can I say subscribers who have subscribed to this event. Okay, so there's why? Because once the event has been done, once the event has been occurred, these event subscribers want to know, right? Yes, the event has been happened. So the same thing. What do you see in your use cases, guys? Like how newsletter has been publishing to all the people, and how a group common mail email will be given to all of you to make sure that this event is happening at this particular place. The same concept in terms of in SNS2. Okay, and each subscriber to the topic will get all their messages, and this is the limit what we have. So almost we have 12 crores of 5 lakh subscriptions per topic and 1 lakh topics limit which is available. With SQS, we do have subscribers like SQS can be integrated as one of the subscriber. Lambda function can be integrated as one of the subscriber. Kinesis data firehorse, emails, SMS, HTTPS connections, and lot, because they can be integrated with any kind of AWS services. And those AWS services will be the subscribers for the SNS topic, which is being created in the particular circumstances. Okay. And MQ. MQ, so far so good, right? So far, so good. We talked about SQS, SNS. Why? Because SQS, SNS are cloud native service, the property protocols from AWS. Okay, but why? Because AWS has provided those things. Instead of providing a direct integration to the what makes it direct integration for the cloud application part, like we need to have a queue service in such a way that based on the priority, the integration will be upgraded. And based on the notification part, we can also provide simple notification service. But if your application uses some traditional protocols such as MQTT, AMQP, Storm, OpenWire, and WSS. So MQTT is nothing but the message queuing telemetry transport. So which is a protocol, is a message. If you want, you can note it, guys, but because I'm not much aware about this thing. Because whenever I learn, I try to make sure to put it as something. What is the difference between these things? Okay, so it's a message queuing telemetry protocol, sorry, telemetry transport. So it is one of the important protocol, guys. Okay, it's one of the important protocol which helps with IoT IoT device message connections. And AMQP stands for Advanced Message Queuing Protocol. Why? Because Advanced Message Queuing Protocol, this is also same as message connection only for the IoT devices. And Stomp is nothing but simple, or you can also provide streaming text-oriented protocol where based only on text. So Stomp will be working only in based off text, right? So if if your application, okay, if your application is using any one of these protocols, then what you have to do, you are supposed to change this protocol, run inside SQS and run inside SNS. It is a very tedious thing, right? You have to re-engineer the entire application running rather from this what I say traditional protocols to SQS and SNS. Can we have another option? Yes, it is available. That's the service called as Amazon MQ. Okay, Amazon MQ is a managed message broker service which has integration with RabbitMQ and ActiveMQ. RabbitMQ and ActiveMQ are the what may I say integrations and are the what may I say it is an protocol services which provides you for integration with other integration with applications, right? And very important thing, MQ doesn't scale as much as SQS and SNS, and it runs on servers, can run in multi-AZ with failover, and MQ has both queue feature and topic features. It has both SQS and both, what may I say, both SQS and both SNS too, right? So that's the end of today. So let's see some of the summary of these source services. So first thing, we talked about the other compute services, guys. So we talked about Docker and we talked about containerization. First, we talked about what is mean by Docker and what is the main usage about Docker. Like if the application doesn't meet your compatibility issues, we try to push it as in container images inside the containers, and other the receiving parties can able to use the particular container images. They can just run the container image and to make sure to run their application. And Docker provides the public Docker hub, which I have shown you, which consists of a lot of container images like OS container images, Ubuntu, Linux, and we also have Python, Java, Node.js, etc. So, do we have any other offering in AWS like the registry option? Yes, it is available, which is called as ECR. ECR is an elastic container registry which provides you a private registry option to store your Docker images. And to run your Docker images stored inside ECR, there are two different services. ECS is an elastic container service which helps you to run your server. It's just to run your Docker images present inside your elastic container registry with the help of infrastructure needed by integrating with EC2 instances. And do we need a serverless offering? Then go ahead with Fargate. Then we moved into serverless. And as I said, please don't think that serverless is nothing but there is no virtual servers at all. You don't manage that, you don't provision that, and you don't scale that. Okay, AWS will take care about it. You don't see that at all. That's why the word serverless came. Please try to make sure that put it inside your mind. And we talked about one of the pioneers of AWS serverless offering, which is a Lambda, the function as a service. I would say it's a serverless function as a service, which helps for event connections. If any event has been happened, the Lambda function will get triggered, and to make sure that the listings which is available inside your Lambda functions will be automatically done. Okay. Then we talked about Lightsail. Lightsail is one of the important serverless offering of AWS, which provides like if you are a newbie developer, want to use cloud, don't want to what may I say, fix your mind that cloud is very costly. Like I can't able to easy predict my pricing, but you do have a service. Yes, you do have. Please go and use Lightsail, which helps you to scale up your applications. And API Gateway is another serverless offering which tries to integrate your APIs, create or update or delete your APIs, and it is being integrated with lots of other third-party APIs called as RESTful APIs and Postman APIs, etc. Batch is another serverless offering which helps you to provide batch-oriented services and is being stored as a Docker images and runs with ECS. We can also run with Fargate if it is needed. And today we also seen about cloud integration. Cloud integration is nothing but we talked about how to integrate your services within on-premises services to the AWS, and how do we integrate it. Instead of direct integration, we can provide some other kind of integration with the help of queue model, with the help of topic models, which is coming with simple queue service, simple notification service, and we talked about Kinesis. Kinesis nothing but the real-time streaming data. If you want your real-time streaming data integrated with AWS Cloud, Kinesis is one of the offering what you need to know. And Kinesis has four offerings. Kinesis data streams, which helps in data. Kinesis video streams, which helps in online video streaming part. And Kinesis data analytics to analyze the data, what has been, analyze your real-time streaming, which has been pulled in by data streams or video streams. And Kinesis data firehose is used for real-time ETL process. That means extract, transform, load. And MQ is one of the other servers at the last we see for if any other applications using uh, the other protocols like the MQTT, MQP, and Stomp. We don't want to re-engineer application into SQS and SNS. Rather than that, what you can do, you can use Amazon MQ, one of the other offering, which has been integrated with Rapid MQ and Active MQ. And Amazon MQ, as I said, so Amazon MQ, you can run either your SQS topics or like the SQS queue models, or you can also run with SNS topics too. So this is what I would like to convey today. And if you have any doubts, like we do have almost 15 more minutes. And if you have doubts, you can ask. Or else, if you want to go ahead with the tomorrow's portion, we'll just see a little bit today and we'll get into tomorrow's. That's your wish. So if you're saying that's the thing.
Hello.
Yes.
Yeah. Hi, sir. Could you please explain like what is Docker containers? I mean, Docker image.
Mm, let's say. Okay. So let's say you're creating an application, like a full stack application. Okay. So it
Mm-hmm.
contains both front end and back end. Front end you have
Okay.
created with React, and back end you have created with Python. Just a sample example. Okay, I'm just giving you an example.
I came from non-IT background, so yeah.
Just to give me a minute. Just give me a minute.
Mm-hmm. Mm-hmm.
Okay, that's fine. Okay, let's say you're creating an application, right? That's a front
Mm-hmm.
end. I will give you an other example. Like you're creating an application called where is it? Like an e-commerce application. Okay,
Okay. Okay.
so which has a beautiful front end for you, which helps you to click your which helps you to select your products what you needed, right? And
Okay.
these number of products are stored inside a backend called as database, where it contains a lot of other things like the number of products which is available in the particular store. So can you able to see the flow? What I'm trying to push you to you?
Yes, sir.
Okay, so good. Now we want to make sure that since the application is being created by you, now I want to use the application. What you will do? Just go ahead, go ahead. Why? Because only if you try to answer, I can able to explain you in such a way that how Docker is being used and how Docker is. Okay. Now the thing is, now the product has been created by you. Now you're the one who's created that application. Now I want to use the application. How to do it? Just provide me in the layman terms. No issues. There is no wrong at all.
I'll push that application to the S3 bucket.
No. Don't go ahead with Amazon. Okay. I'm just
Mhm.
telling to you, right? Just don't go ahead with AWS Cloud at all. Okay. I want to use the application. What I have to do? So you'll be creating your what may I say. You'll have that particular URL, right? You'll share me the URL.
Yeah. Yes, sir.
Okay. Or else what you do
Yes,
nothing
sir.
but you will be writing all the code. You will be sharing me the code. This is what a
Yeah.
simple thing what you'll do, right? This is what a simple thing what you
Yes,
do.
sir.
But
Yes, sir.
unfortunately, what happened is nothing but you are developing an application with some system capabilities, right? You are working with Windows almost more 10, Windows 10, and RAM with
Mm-hmm.
16 gigabytes of RAM, and
Okay.
storage with 512 gigabytes of storage, and some kind of GPU are also running with it. Okay, but unfortunately, I am not running with that same kind of configuration what you have. Okay,
Okay.
because I don't have that. I do have only Windows XP in my laptop, and I'm only having
Mm-hmm.
2 gigabytes of RAM and 30 gigabytes of
Okay.
storage. Just very less
No.
compared to you what you have developed. Can you just say,
Okay.
can I able to use the application in my laptop?
Mm.
Why? Because since you have created in such a platform, such a way that that application will run only when I have what may I say this
The
amount of capacity.
accessibility.
Yes.
Yes,
Now,
sir.
if I
Yes, sir.
want to use the same, why? Because now as a developer, what you will think is that every customer want to use my product, but unfortunately, this
Yeah.
has a lot of discrepancies, like
Yeah.
the system capabilities. So you
Mm-hmm.
can't able to predict in advance, right? Every customers, everyone who's using my product will have the same thing, same capabilities what I have.
Yeah.
Okay, so that's there the containerization part is being done. So what Docker provides you is that Docker provides you a software development platform. It will provide you a software where what you can do something. But you said that you'll be giving me the whole code, right? Instead,
Yes,
you
sir.
won't give me the whole code. You will
Yeah.
make sure that you'll push those whole code as a Docker image. Okay.
Okay.
What the
Okay.
Docker image will consist of that? Docker image will consist of all the listings, like what and all needed for that particular application to run, rather
Okay.
than the consistent
Got it.
capabilities, like rather than the OS,
Mm-hmm.
rather than the RAM, ROM, etc. Instead, it also have
Okay.
all the software listing which is available inside the Docker image. Then the Docker image should have a kind of storage option where I can able to use it, right? A public storage option where I able to use it. That's where
Yes,
Docker
sir.
provides you a Docker hub where you can able to store your Docker images. Right
Okay.
now, so far your job is done. Now you have done your job. Now I want to use that application. What I'll do something, but I'll go to the Docker hub. I'll
Mm-hmm.
take the Docker image. I'll just simply run the Docker image rather than creating all the updates and proving putting all my code inside. I don't do all those things. I'll just take the Docker image and run it to make sure that now your application will run from a particular platform. Why? Because it doesn't take any kind of compatibility. Why? Because it's a Docker image. It doesn't have any
Yeah.
compatibility issues over there. Just the software
Okay.
needed. Now I'm trying to able to run your application. This is called as
Okay.
Docker. This is called the concept called as containerization. The code what you have created, the application what you have created, you are converting that to an containerized application, and you are making to provide it as containers. Docker images. You are pushing this Docker images to a Docker containers, and that which is available inside my public Docker hub. With the help of public Docker hub, I can able to access the public Docker hub, take the container images, run it. I can able to use your product. I don't want to care about any kind of compatibility issues which is available inside my system. Got it?
Yes, sir. Thank you so much.
Thank you.
Thank you.
Sorry guys, I can't able to see the chat. Yeah, someone something in chat. I can. Okay. When will AWS allocate EC2 serverless resources to Lambda? I mean, at the time we create the Lambda or only during the Lambda execution. Let's say I create a Lambda and I wrote the function and didn't execute the function for a week. So during this week time, AWS reserve the resources for this idle week time also, even though it was not running. I can able to get a particular thing done. Can you just switch on your mic and just ask a question?
Sir. Hello?
Yeah.
Yeah. So my question is, let's say if I create a Lambda and we use it for some time, and you said like Lambda serverless, right? Which means like it will take the resources automatically. AWS will allocate the resources. As a developer, we don't need to give any resource, right? Even though function has to be executed by EC2, which means that EC2 will be
Wait. How the
so
functions will be executed?
Whether do I need to pay for it when the Lambda is created, function is created, even that is not executed?
Guy, let's just listen. I want to put you on a scale, right? Okay. The thing is, when you are just saying that if the Lambda has not been executed at all, do you want to pay for the Lambda resources what is been scaled, right?
Yeah.
That's what the question you're asking.
Right.
Yes. So one important thing is nothing but only when the Lambda has been executed, the other things like where I've seen some sample architecture here, like the thumbnail thing. Only when the event has been happened, the Lambda will get triggered, and the Lambda will create two important thumbnails. Two important things. It will reduce the size of an image, put it inside the same S3 bucket, and store the metadata inside the DynamoDB. If it is not executed, do I want to pay for the resources? What the Lambda resources want to do it? No, right?
Okay.
So that's what I need to review on it. So that's actually doesn't mean that for big part.
Okay. Which means even though Lambda is not executed, AWS won't charge us, right? Even if I create it.
Only when the AWS is being, only when the Lambda has been charged, because the Lambda has been triggered, you are supposed to charge for it. That's it.
Okay. Got it. But even if I don't execute it, but still AWS Lambda will have the resources assigned to that, right?
Yes.
Like each.
Yes. You'll be writing the functions. You'll be
back.
writing the destination. Yes.
Yeah. So one more thing regarding the API gateway. So you said like API gateway is kind of a proxy between
Mhm,
each services, right?
mhm.
Uh, but if I have a, let's say, API developed by someone else, and if they expose it, if I want to hit it through browser or something like Get API or something like that, if
Mhm.
I want to do that, I can directly call their API, right? Why do I need API gateway here? Sorry, I'm trying to understand the need for API gateway.
Okay. If you want to push your anything inside your cloud, what do you have to do? Which runs in the API.
Mhm.
That's why API gateway. That's it. Why? Because listen. So the thing with API gateway is that API gateway will create you the proxy requests is what you needed for the application, what is going to run in it. Right? That's for the major concept. Okay. You are saying that you're going to create an own API and what is it? Own API and pushing inside the thing. What is the use of API gateway then? So
Right.
this was the
Yeah.
question, right? So
Yes.
API gateway will run in such a way that API gate. What if you have an application that is being integrated with AWS Cloud? But unfortunately, your application will be using some kind of RESTful APIs or other third-party APIs or other APIs what you are trying to push it over. But unfortunately, you have to store the API. You have to what may say store the requests which has been accessing through the API right inside your AWS cloud, either in the DynamoDB, either in the Redshift, or either in the any kind of database. What you think? But how do you do that? You need a gateway to access the APIs, which is right. Either it is a third-party API, either it's the own API what you create, right? You need a gateway to access the APIs what you have create, right? That's the API gateway is offering for you.
Is it before the load balancer, sir, or is it after the load balancer? How that architecture will be? Like API gateway will be before the from the user it will go to API gateway and then load balancer to
Ah,
system.
that's I'll just show you the what may I say just the overview about the API gateway. Right? Because there are a lot to know about API gateway. If you just see the
Oh,
entire architecture, you'll be seeing a lot of things. You'll be using CloudFriend, you'll be using CloudWatch, you'll be make sure to there are a lot of security services you need to adjust first, then you have to go for the API gateway. Okay.
okay.
Because API is the one what you have created. Like there'll be a lot of security measures should be taken so far. So the architecture will be somewhat elongated and can be stretched.
Okay. Got it. Got it.
Thank
Actually,
you.
last question, sir. Yeah, last question. One more doubt. Actually, this is one of the entry question recently asked. One of my project. They asked me about like, let's say you have a database which is on-premise, and if my application wants to go to AWS, okay, but still database wants to be in on-premise. They asked me like what service we have to use in AWS and how to achieve that. If possible, can you please explain that at least high level, if possible, time permits.
Um,
Application
okay.
has to go to AWS, but database still has to be in on-premise. And how to achieve this? Um, is there any service that in AWS offers to connect?
Okay. Just post the question in the WhatsApp group. I'll answer.
Sure, sure. Thank
Is there any other questions you have? And guys, the pre-booking. Okay. So as I said in the beginning, so the pre-booking has been started for your cloud developer associate, and the portions are also being shared. What are the syllabus? What are the services? And how long we are going to spend on the services all being shared. Okay, that's very important because, as I said, um, for serverless thing we have just covered within 45 minutes, right? But serverless need more than 4 hours of training. Okay, serverless needs more than 4 hours of training. We just seen only 4 different types of services in serverless. Okay, if I'm not wrong with the number of services, I can't even do. So you need a lot of services, a lot of understanding behind the serverless. So Cloud Developer Associate will give you all those things, and we are happy that CDP Networks is providing 50% off on your Cloud Certified Developer Associate training, and it commences from 16th of December, and just for 15,000, right? So and they also posted lots of things. Go ahead. You may able to find the pre-booking link now. Also in the chat, you can able to see the pre-booking link, and you can also see the pre-booking link in the description of the WhatsApp group too. Go ahead and pre-book yourself and get what may I say master in AWS as a developer. That's very important. Why? Because those who are developer out there, please grab the opportunity. Why? Because it will help you a lot to gain the knowledge.
you. Should I go for developer associate or is it a solution architect, sir? Which one? What is the difference actually between these two certificates?
think so. You have to see the first demo video what I conducted. Okay, I've shown almost all the list of AWS certifications available, right? Where that's your choice. Whether you have to go for developer or whether you have to go for solution architect, it's your particular point of view. I don't know about your background, what you're working, right? That's your major thing.
Java developer. Okay.
So it's like we need to know about lot about like whether you are working in a. So go ahead and watch the demo video. Right, first
Okay.
thing, the first demo video what we conducted. Like I've shown you a lot of AWS services. Those who are in the particular background, which AWS services you should take, and what is the particular gate pathway you have to take it to make sure to available as an AWS cloud. So that will help. So you have the AWS demo batch link. Go ahead and watch.
Yes, sir, I will do it. But developer means, do I need to develop any APIs in AWS?
Yeah, sure. You'll be creating your own applications inside AWS itself.
Oh, I see. Okay. Okay. Thank you, sir.
Thank you. Is there any other queries, guys? Do we have any other queries that we can answer? Okay, if there is no queries, we can end up a class. Okay, so today we have seen seen so much of things. Like tomorrow we'll be delving into one of my favorite offering of AWS, which is Amazon Machine Learning Services. And we'll be trying. I will not be covering anywhere because covering any hands-on in AWS machine learning. Why? Because it will cost me more. Yeah, actually, it will cost more to use your Yes, you can able to see the schedule. You can able to see the syllabus in the WhatsApp groups itself. Right now, they have posted the thing. You can just look at the developer team. Right. So thank you for attending. So tomorrow we'll be delving into Amazon machine learning services, and we'll also delving into security and compliance security services. We'll be delving into some of the major services what we have, and we'll try much to cover a lot of things in the next class. Right. So if you have any other queries, you can just post that in the WhatsApp group. I'll answer as quick as possible, and we'll all meet tomorrow with other new learning. Thank you. Bye bye.